Hi everyone. Have you ever been confused or annoyed when reading and you see that this is obvious to see that it is easy to show that on this left for exercise or something else? Here, this is nothing obvious, and in this script we will talk about transition matrix. The transition matrix, also known as a change of basis metric or metric of change of coordinates. This matrix will play a crucial role in changing a coordinate system. Okay, let's begin. We have a coordinate system called xy coordinates with basis b, which contains a ex and ey. We call this coordinate as a Cartesian coordinate. And if we like to change this coordinate to another coordinate system called the psi eta coordinates with the basis b prime, which contain the e psi and e eta as the basis vectors. We call this kind of coordinate system as the oblique coordinate. And how can you change under the coordinate system? So we just focus on the basis vectors of the xy coordinate, and we have to find that each basis vector, how does it map to the not to the new coordinate system. So we have to write the ex and ey in terms of e psi and e eta. In the case of ex, it's just exactly the same as the e psi, and for the ey, it's just a little bit more complicated. So we have to add a additional segment here, which is the beta in the direction of the e eta, and the quantity alpha, which is the in the direction that parallel to the e psi direction. And then we have to use the maybe the Pythagoras formula to find the constant alpha and beta, and we have this one which is equal to minus cos theta and cosec theta. Therefore, we can write the expression of the ex which mapped to the e psi and e eta in terms of the coordinate vector, which means that the ex in the Cartesian coordinate can be mapped or can be written in terms of the b prime basis to be the vector 1, 0. Similarly, the EY, which mapped into the new coordinate system psi eta, which has the basis b prime, it can be written as a minus cot theta and cosec theta. So for any vector v in a vector space, which in the Cartesian coordinate, we can write them in terms of the linear combination of ex and ey, where vx and vy are the components of the v. And from the previous slide, which we have discussed about the ex and ey in terms of the new coordinate system psi eta. So we write them down in terms of the e psi and e eta. And we may write them in terms of the metric metric expression. So we have the coordinate vector with respect to the b prime basis and the coordinate vector with respect to the b basis. And we call this kind of matrix as a transition matrix or change of coordinates matrix. And we usually denote this metric by p or p sub b comma b prime, which means this metric will change the coordinate which has the basis b to the new coordinate which has the basis b prime. Okay, if we consider the p closely, we find that the component or the law of the basics or this each com okay, if we look at the transition matrix closely, we will see that each column of the matrix is composed by the coordinate vector of the basis because the EX in terms of the basis B prime can be written as 1, 0. Similarly, EY with respect to the new basis B prime can be written as minus cot theta and cosec theta. So the transition matrix can be constructed by composed or by combining each column vector of the coordinate vector of the all basis vectors. And in general, for the finite dimensional vector space, the transition matrix P can be constructed in the same way by by combining the coordinate vector of E1 to the En with respect to the new basis B prime. And uh, in other words, and conversely, if we now in the psi eta coordinates, and we're gonna map these coordinate into the Cartesian one. So we just follow the similar process by writing E psi and E eta in terms of the basis vector of the xy coordinate. And then we have the coordinate vectors for the basic vectors in their own coordinate, which is the psi eta. So the transition matrix can be constructed by grouping the coordinate vector of the basic vectors, which is equal to 1 cos theta 0 sine theta. And we can see that this one p b prime comma b, which means we gonna transform the coordinate vector from b prime to b. And if we transform this coordinate and we transform back again to the own and original basis or coordinate, so we should get the identity map, which means we didn't map anything. Okay, so the transition matrix B prime B times P B B prime will result in the identity matrix, which means that we map to new basis or we map to a new coordinate and we just map back to the original one. So it's result in it should be in the same position. And that is the transition matrix.